Hello class. What we're going to be working with today is the naming molecular compounds POGL, which you should have out in front of you. We're going to do that together. But right now what I want you to go ahead and do is flip all the way to the back, and we're going to take some real quick notes over covalent compounds. So our goal today is naming and formula writing for covalent compounds. So at times during this video you may need to pause it just to catch up, so just be aware of that. So let's just get a quick definition for covalent compounds. Up to this point what we've been dealing with is ionic compounds. In a covalent compound what you have is non-metal atoms bonded together. So in the ionic we had a metal and a non-metal, and they were ions. Here now we have atoms, and that's important because in the covalent compound there are no charges. This is where a lot of people kind of mess up because they look at the charges. No charges or ions in covalent. And that usually messes people up because we deal with the charges in the ionic, not in covalent at all. So since there's no ions or charges, there has to be some type of different way of naming them and writing their formulas. So that's what we're going to try to discover in this video. So if I could have you go ahead and skip ahead and go to page 2, model 2. We're going to do this. So page 2, model 2. And the first thing what we want to do is number 5. It says examine the prefixes in model 2. Fill in the numerical value that corresponds with each prefix. Well, mono is 1, 2 is di is 2. So you can pretty much just figure out the rest, and go ahead and take this time to fill these in. So you have all 10. So the prefixes in front match these numbers that we have here. So that was number 5. Number 6 says what suffix ending, so the ending, do all the compounds names have in common in model 2. So let's go back to model 2. Here's a model 2, and we're looking at the suffix now. And each time at the very end, again, it's that "-ide". So we still have the second vowel rule in place, where we go to the second vowel, cross it out, replace with "-ide". So let's fill in that answer for number 6. The suffix is "-ide", and we're to still follow second vowel rule. So that's something that's actually similar to the ionic, with the non-metal, the second non-metal's names changing following the second vowel rule. Alright, so let's look at number 7. In number 7 it says carefully examine the names of the compounds in model 2. When is a prefix not used in front of the name of an element? So before we do that, let's look at when they are used, and let's just mark all the times that they are used, and whenever they're not used, then that's going to be our way to kind of figure that out. So going back here, let's just make sure we understand what a prefix is. That's these right here, the mono, the di, the tri, the tetra, penta, hexa, all those names corresponding to the numbers. So let's look at when are they used. In boron and trichloride, we have the tri. Here we have hexa, hepta, tri, tetra, mono, deca, nona, octa, mono. So every single time on the second one, every single second non-metal has it. There's not a single case that it's not there. Now let's look at the first atom in the compound. We have boron, and that one doesn't have a prefix. No prefix. There's a missing prefix here. Missing prefix on the next one is just sulfur, iodine as well, nitrogen as well. But then if we keep going, we see that we have dinitrogen, dichlorine, tetraphosphorus. So we have some prefix, and then on that last one there, we notice chlorine doesn't have a prefix. So there's only a couple cases where we don't have a prefix. In this example, we only have 5 cases where we don't have a prefix. So let's examine why don't these have a prefix. So let's look at the ones that don't have a prefix. So I'm just going to circle those real quick, those formulas. And when we look at these formulas, what we should notice that is really unique just to these formulas and none of the other ones is that the first atom, first element, there's only one atom in the formula each time. Each time there's only going to be one atom. And so what we see there is when we only have one atom, we never put a prefix on that first element, the mono. So the mono is left off the first element. That's when we don't use a prefix. That doesn't mean that we never use mono. If we look at this Cl2O, we get the name dichlorine monoxide. So we do use the mono, but we only use it on the second atom being named, or the second element being named. Every single time, the second element always has to have a prefix, and the first element always has to have a prefix as well, unless there's only one of that particular element, and like in these cases. So we never start off saying mono, but mono can be used for the second element. Let's write our answer to number 7 now. So we examined it. We found that the only time a prefix is not used is mono on the first element. It can be used on the second element, it just can't be used on the first element. Di can be used on the first element, tri, all the other prefixes, the only one is mono. Mono is the only one that we will not use on the first element. So let's move on to number 8. It says consider the compound NO. Which element, nitrogen or oxygen, would require a prefix in the molecule name, and explain your answer. And then it says part B, let's name the molecule NO. So we have nitrogen and oxygen. The nitrogen, there's only one of them. The prefix for one is mono, so that won't get it because it's the first one. And then the second one is oxygen, and we already know no matter what, the second element always gets a prefix. And since there's only one oxygen, it would be mono. So we can go ahead and answer this. This would be oxygen, and we're saying that because it is the second element in a covalent compound. All right. And then it says, let's go ahead and name this molecule. Well, N is nitrogen, and there's only one in there. There's no number next to it, though that means 1. And that one doesn't get a prefix because it's the first one and it's 1. And then we have oxygen, which since it's the second one will be oxide. And since it's covalent, it should have a prefix, and the prefix just tells me how many of that particular atom I have. Well, how many oxygens do I have? There's no number, so we have to assume it to be 1. And the prefix for 1 is mono. You don't need to put the second O there. So it's nitrogen monoxide. Alright, so let's skip ahead and let's go ahead and go to page 4. And we're going to do 17 and 18, and we're actually going to practice naming our covalent compounds and then also writing the formula. And you're going to see this is way, 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 way easier than the ionic. You don't need to do anything with charges or anything, right? I mean, you don't even hardly have to look at the periodic table because all the information is given to you right there. So when we look at this, the first name never changes. We don't use the second vowel rule. We only use that on the second atom. So the first atom we never use it. So when we look at this first one here, where we have PBr3, just go ahead and name the first thing there, which is phosphorus. Nothing about the name changed. That's just the name straight off the periodic table. Look at your periodic table. It's right there, number 15. That's it. And then you want to see how many of those do we have. Well, we just have a P and there's no number. If there's no number, it just means 1. The prefix for 1 is mono. And what we just learned is that the first element never gets mono. So that first prefix, there's no prefix for that first one. Then you have Br. If you look at Br on the periodic table, you'll see bromine. But remember, since it's the second element, you need to use the second vowel rule. So first vowel being the O, second vowel I, cross it out, replace with I-D-E. So it would be bromide. Bromide. And then you have to look at how many bromides do I have. I have 3 bromides. I see that in the formula. The prefix for 3 is tri, so you put that right in front. So phosphorus, tribromide. That's it. Real easy. Let's go ahead and finish these up. So the next one, we have S, looking it up on the periodic table. That's just sulfur. Name doesn't change because it's the first one. Then the Cl, chlorine. I'm sure everybody already knows that by now. Cross out the I and everything behind it. Put ide. So we have chloride. And then now it's time for the prefixes. Sulfur, there's only one of them. And the first one never gets mono, so that can't get the mono. So sulfur's done. And then we have the chloride, and there's 4 chlorides. So you go 4, oh, that's tetra. So we put tetra. So we have sulfur tetrachloride. Let's look at the next one. The next one we have N2F2. N, we should know, is nitrogen. Remember, the name didn't change. Then we have fluorine. Second vowel rule, cross out the I-N-E, put ide. So we have fluoride. And then you look at for the prefixes. Nitrogen, there's 2 of them. So that would get a di. That's our first element that has a prefix. It does get the di because the only one it doesn't get is mono. So it gets di because there's 2 of them. And then we have difluoride. So go ahead and do the other 2 on your own. But as a class, let's go ahead and move to number 18. In number 18, we're writing the formulas. Sometimes people have a little bit of difficulty with this because they put the numbers in the wrong spot. Just be careful. The number for that for whatever element you have goes after the symbol. So the first one here, we have sulfur and fluoride. So we have S and F. How many sulfurs do I have? Well, in front of it has a di. Di means 2, so I have 2 sulfurs. In front of the fluoride, I have deca. Deca means 10, so I have 10 of those. That's it. That's how you write the formula. No charges involved. All the information is right there for you. Let's look at another one. The next one we have is carbon, C, and then we have chloride, which we know is Cl. Carbon, there's no prefix. Well, if there's no prefix, we know the only time in a covalent compound that there's no prefix, that means mono, 1, and we never write the 1s, so we just have the C. And then we have tetra, tetra meaning 4. So you have 4 chlorides. That's it. Let's look at this very last one because people may look at that last one and be kind of scared. It's really easy. You have phosphorus, P. Sulfide, we should know is S. Well, how many phosphorus do I have? Look in front. Tetra, meaning 4. How many sulfurs do I have? Hepta, meaning 7. That's it. I just wrote the formula. So the covalent compounds are real easy to write the formulas and write the names. They're way easier than the ionic. A lot less rules. Alright, so one final thing I want to do with you, if we can move all the way to the very end, page 6, number 21. In this problem, this is where your quiz looks like. This is what your test over this stuff is going to look, very similar to this. So you have ionic and covalent all mixed together. You have to figure out what it is, what compound it is, and then be able to name it. Remember, ionic and covalent have 2 different naming styles. So you have to get those rules right to be able to do that. So I want to show you a couple examples on number 21 just to make sure that we all understand how to do this. So remember, very first thing it says right here, type of compound or bonding. So you have to figure out, is this ionic or is this covalent? You may have forgot how to do that, so I just want to really quickly just put it up here just in case you forgot. Ionic, you have a metal and a non-metal, and they have their own rules. And then covalent is what we did today, and you should know that that's just non-metals only. So you have 2 non-metals or 3 non-metals, but it's only non-metals, there's no metal involved. And remember, these both have 2 different naming and formula writing rules. So when we look at this first one here, we have CS2. Well, C is carbon, which is a nonmetal. S is sulfur, which is a nonmetal. So when they ask us what type of compound this is, that would be covalent. It's a covalent compound. And then we have to use the covalent way to name. In the covalent way to name, we have prefixes. So we say C is carbon. The prefix for carbon here would be 1, mono, but we know the first one never gets mono, so it's just carbon. And then you have sulfide. We know the prefix for sulfide is going to be 2 because we have 2 sulfurs there, so this should be disulfide. So that's pretty easy because that's something that we've done today. But this next one you may have forgotten about. So if we look at, let's skip the PBI and let's go to BaCl2. Well, the type of compound that is ionic, because I have a metal and a nonmetal. And so when we name ionic, there's no prefixes whatsoever used no matter what. There's no prefixes. So Ba is barium, Cl is chlorine, it'd be chloride. Even though there's 2, there could be 100 of them, it doesn't matter. We don't put a prefix for the ionic. So when it's ionic, no prefixes whatsoever. So that was writing the name. So now let's just review writing the formula. Just do a couple of those, and then you can get started on your work for the day. So let's look at this first one. Xenon tetrafluoride. You have to determine, is this ionic or covalent? Now we're working backwards here. So xenon is covalent, so is fluoride, or they're both nonmetals, so it's covalent. Xenon, the formula for that is Xe. Get that right off the periodic table. Since there's no prefix, we assume it to be 1. So there's 1 there, we don't put the 1s. And then fluoride, fluoride is F. Tetra meaning 4. So there's 4 Fs. Done. Remember, ionic is a little bit different. Ionic is made out of ions. They have charges, and you need to make sure that the charges are balanced. So this is sodium phosphide. We know this is going to be ionic because I have a metal and a nonmetal. Sodium, its charge is +1. Phosphide, P, is a -3. So again, when we're looking at this, this only happens when we have ionic, when they are charged. When it's covalent, we didn't do anything with these charges at all. There's no charges at all when we wrote covalent, only when we write ionic. And we have to make sure that these charges are balanced. So since I have a -3 and a +1, I need more +1s to balance that -3 charge out. So now what we want to look at is not just the charge. Now that the charges are balanced, we don't want to look at the charge. We want to see how many of each one of these that we have. I have Na, there's one there, there, there. So I have 3 to the 1p. So when I write my formula, I put in A. How many did I have? 3. So there's 3. And then I have my P. How many of those have? I only have the 1. Oh, but we don't put the 1, so take that off there. There we go. Na3P. And then we are done. Thank you for watching this video. Hopefully it kind of makes sense. If you need to rewatch it, it'll be on my YouTube channel, Mr. Coach Beck's class. You can rewatch it as many times as you need. Rewatch the parts, only the parts that you need, and hopefully this will help you when we take the quiz. Thanks.